Good morning, everyone. Today, we are diving into one of the most essential systems in modern vehicles, the electrical systems. As you know, cars are becoming more and more like computers on wheels. Everything from your car's entertainment systems to its engine management relies on electrical and electronic systems. So this is the first lecture on these basic electrical systems. We need to study these basic electrical systems in order to operate the different electrical systems and to repair and diagnose the problems in the electrical systems of our automobiles. Imagine being a technician who can understand and repair these sophisticated electrical systems and electronic systems. You would be a very indispensable to the automobile industry. For instance, modern vehicles use electronic control units, we call them ECUs, to manage various functions like fuel injection, anti-skid braking systems, and even the air conditioning systems. This complexity makes it crucial for us to understand the basics of automotive electrical systems. Having knowledge of automotive electrical systems can open up a world of opportunities in the industry. As cars continue to evolve with advanced technology, with the right skills, you can stay ahead of the curve and be a valuable asset in the field of automotive maintenance and repair. Now, understanding electricity. Let's start with the fundamentals. Our universe is composed of matter, which include anything and has mass and occupies space. All matter is made from elements which are pure substances consisting of only one type of atom. For example, gold is an element, and a piece of pure gold is made of extremely or entirely of gold atoms. Atoms are the smallest particle of an element that retains the property of that element. To give you an analogy, think of an atom like a miniature solar system. In an atom, electrons orbit the nucleus, which contains protons and neutrons. Just like planets orbit the sun, electrons move around the nucleus. The structure is essential for understanding how electricity works and interacts with each other. For example, the arrangement of electrons in an atom determines its chemical properties and reactivity. This knowledge has led to advancement in various fields such as chemistry, physics, and material science. Now, what exactly is electricity? Simply put, electricity is the movement of electrons from one atom to another. The dense center of each atom, called the nucleus, contains protons with positive charge and neutrons with no charge. Electrons, which have a negative charge, orbit the nucleus in various energy levels or shells. An atom typically has an equal number of electrons and protons, making it electrically neutral. To give you a sense of scale, if an atom nucleus were the size of a period at the end of this sentence, the entire atom could be larger than a house. This is similar to how a car battery, despite of its compact size, can store a significant amount of energy to power the various systems. Atoms are the building blocks of matter and are incredibly small yet complex structures. Now we have to see the positive and negative charges. Understanding the concept of charges is very crucial. Electrons are negatively charged while protons are positively charged. These charges are represented by minus and plus signs respectively. Neutrons, on the other hand, have no charge and neutral. In an electrical circuit, these charges plays a vital role. For instance, in your car battery, the positive terminal is marked with a plus sign and negative terminal is marked with a minus sign. When you connect a battery to the circuit, electrons flow from the high potential, that is the positive terminal, to negative terminal, powering various components like starter motor and headlights. Understanding the flow of electrons is essential in designing and troubleshooting electrical systems. This movement of electrons creates the electric current necessary for devices to function properly. In a balanced atom, the number of negative electrons equals the number of positive protons. This balance is crucial for stability of the atoms. Think of it like balancing the wheels of a car. Just as balanced wheels are essential for a smooth ride, balanced atoms are essential for stability. In automotive terms, an imbalance in the atom's electrons can be likened to unbalanced tires on a vehicle, which can lead to bumpy and unstable ride. Similarly, unbalanced atoms can lead to instability at the atomic level. Maintaining this balance allows the atom to form bonds with other atoms, creating molecules and compounds. This stability is the fundamental to the functioning of all the matter in the universe. Now, the next important concept of attraction and repulsion of charges. One of the fundamental principles of electricity is that opposite charges attract and like charges repel. This is similar to how magnet works. Opposite poles attract and like poles repel. This principle helps explain why negative electrons are attracted to positive protons and why they continue to orbit the nucleus. In a car's alternator, this concept is utilized to generate electricity. The magnetic fields created by the movement of electrons within the alternator helps to produce the electrical energy needed to recharge the battery and power the electrical systems when the engine is running. Understanding the principle of attraction and repulsion between the charges is essential in various applications, from basic electrical circuit to the complex machinery. Now, an unbalanced atoms and we can say the ions. The next important term unbalanced atoms and ions. When an atom loses or gains electrons, it becomes unbalanced and is known as an ion. A positively charged ion has more number of protons than electrons, while a negatively charged ion has more electrons than protons. Ions seek to regain balance by exchanging electrons with the neighboring atoms, creating the flow of electric current or electricity. For example, when you turn on your car headlight, the electron flow from the wires creating light. This flow is essential for the movement of electrons from one atom to another, trying to achieve the balance. In nature, ions are constantly forming and breaking apart as they seek stability through the electron exchange. This process is essential for various chemical reactions and functioning of many biological processes. Now here we can see there is the movement of this electron from this atom to this ion. Why this is ion? Because it contains more number of protons than this electrons. It is a positively charged. Now in this case, it was a balanced atom. Now it will contain the less number of electrons as compared to protons. Now in this diagram, you can see the atomic configuration of different elements such as aluminum, copper, and silver. In case of aluminum, there are 3 electrons in the outermost shell. In case of copper, there is 1 electron in the outermost shell. And in case of silver, there is also 1 electron in the outermost shell. In case of aluminum, it is considered as a good conductor of electricity because it consists of less than 4 electrons in its outermost shell. If an atom consists of more than 5 electrons in the outermost shell, they are considered as a bad conductor of electricity and are known as insulators. The insulators also play a vital role in the electrical system. If a current carrying conductor, it should be protected from short circuit or any safety related hazard. We have to insulate this current carrying conductor. So for that purpose, the insulators are used for this insulation purposes. Now, if you see the electron in the outermost shell of the copper is very far away from the nucleus. There are 3 shells between these electrons and the nucleus, and due to which there is a very weak attractive force towards the center of this nucleus. And also, the electrons in these other shells causes a repulsive force on this electron, and due to which there is a tendency of these outermost electrons to drift away from this atom of copper to other atom of copper. And therefore, for this reason, this copper is having higher electrical conductivity as compared to aluminum. Now, in case of the silver, the distance from the nucleus to these electrons is very large as compared to this copper, and also there is more number of, we can say, electrons in the outermost or in these shells, and which causes a repulsive force on these electrons. Therefore, this electrons is having a high possibility of drifting away from this shell to the other atom of silver. Okay, so from this classical theory, we can get the insight of the concept of electrical conductivity of materials. Electrons orbit the nucleus in definite paths and called as shells. Each shell can hold a specific number of electrons. The simplest atom, hydrogen, has one proton, one neutron, and one electron. More complex atoms have more protons, neutrons, and electrons. If there are too many electrons for the closest shell, they will orbit the additional shells with up to 7 shells around a single nucleus. In car batteries, lead and sulfuric acid interacts at the atomic level to store and release the electrical energy. When a battery is used, lead atoms lose electrons, creating a flow of electricity that powers the car electrical system. This flow of electricity is reversed when the battery is recharged, allowing the lead atoms to regain the electrons and store the energy for the further use. This atomic level process is very crucial for functioning of the automobiles, vehicles, and many other electronic devices. The next important concept, the free electrons and bound electrons. The outermost electron shell, known as the valence shell, is crucial for understanding the electricity. The number of electrons in this shell determines the atom's valence, indicating its capacity to combine with other atoms. Atoms with 3 or fewer electrons in the valence shell have loosely held electrons known as free electrons. These electrons can easily move from one atom to another atoms. Now you can see in this figure, there is a concept of free electrons and bound electrons. When you switch on your car headlights, the free electrons flow through the circuit, illuminating the lights. The free electrons are also important in operation of electronic control units, sensors, and various other electronic components in modern vehicles. The movement of free electrons allows for the transmission of signals and data throughout the vehicle system, enabling the efficient and effective communication between the parts. Here we can see this is called as the free electrons, which can move or which is loosely held by the attractive force from the nucleus of these atoms. And these are the bound electrons. They are not easily drifting away from this atom because they are held tightly by the center attractive forces of positively charged protons. Okay. Now, so in this today's lecture, we have seen the concepts of the electricity. Now, understanding these fundamental concepts of electricity and atomic structure is key in mastering the automotive electrical systems. As the vehicle becomes more dependent on electrical components, the demand for the skilled technician will only increase. Imagine being an expert who can troubleshoot and repair the electrical systems of a modern car. Its career path will be full of opportunities. Okay, so thank you for your attention. I hope you found this introduction to automotive electrical systems enlightening. Remembering, just like cars electrical systems, understanding the basics of electricity can drive you towards a successful career in automotive technology. Keep exploring, keep learning, and you will be on your way of becoming an expert in the fascinating field. Remember, the continuous learning and hands-on experience are key of mastering the complexities of automotive electrical system. By staying curious and proactive in your education, you can position yourself for a rewarding and in-demand career in the automotive industry. So thank you for today.